Minimum total distance traveled. This is an interesting question in which you will be given some robots and some factories. So let's look at this diagram. So in this diagram you can see there is a x-axis which is marked as 0, 1, 2, 3, 4, 5, 6, and there are some robots. So first robot is at 0th place, second robot is at 4th place, third robot is at 6th place. So you will be given a robot array, something like this. And then there is another array which is factory, and factory array is mentioned like this. So a factory will have location and the number of robots it can repair. So for the first factory, which is this, it is located at second position and at most it can repair 2 robots. And second factory is at 6th location, and over here capacity is also 2. Now in the given question, all the robots are broken ones, and what we have to do is we need to repair them. And how we can repair them? By bringing these robots to the factory. So to bring this robot to this factory, the distance will be 2 minus 0. So robot will move over here, then here. So first robot took 2 places, and for this robot, in one step he will go over here, then over here. So again 2 steps. In total we have done 4 steps. Now this factory is dead because its capacity was 2 and it has repaired 2. So we will delete this. Now for this robot is already on a factory, so we can repair this with 0 steps. So 4 plus 0 will be 4, and we need to reduce this number. For now it is minimum and hence the output is 4. Let's look at another example. So next example could be this, where robot can go to this factory with 1 step or to this factory with 1 step. So in total 2 steps are there and hence the output is 2. I hope the question is crystal clear. Let's try to look at the intuition part. So first, all the robots should be repaired. Now we have given an robots array that is 0, 4, 6 and factories as this. What brute force approach could be, take one robot, check with all the factories possible. Like for this factory the distance will be 1. For this factory, which is second factory, the distance will be 6. So take the minimum. So now the new factory will be at second position, but the capacity will be 1 because we have repaired this robot. And the second factory is at 6th location and 2 capacity. Now we will come over this robot which is at 4. Now check this, 4 minus 2 is 2, and over here also 4 minus 6 is 2. So we can take either of them. Let's say I take this. Now new factory's capacity will be this. Now we have third robot, check this. So 6 minus 2 will be 4 for this, and 6 minus 6 will be 0, which is shorter. So I will pick this and will make it as 0. But this approach will give you a TLE, and doing this in a greedy way will take a lot of time. So we will look at a better approach, which will be, first of all, sort the robot array. It will be 0, 4, 6. Sort this factory array and try to flatten it into one single array. How we can do is, let's say this is factory array. If I only mark the position, like factories at 2. How many factories are there at 2? It will be 2. So I'll add the number of times. If it would have been 3, then I will add it over here. But currently it's 2. Then we have factory at 6 position. How many factories are there? 2. So we will add 2. Now this is positions array. So what you can do is take this 0, which is robot. Now this is the lowest factory which is possible. You will have 2 choice. Either take it or don't take it. Let's say if you take it, your pointer will be over here. Now you will be at 4th robot. For 4th robot you have 2 options. Either take it, don't take it. If you take it, your factory pointer will be at 6. Now again for 6, you have 2 options. Either take the 6 or skip it. If you skip, you are again at 6. If you take this, you will be over here and you have iterated all the robots. So at last just add their answers, which will be this, and output will be 4. This will be a recursive code. So how we will write this code is, you have got the logic for take and not take. Let's write some base cases. Let's say if we have iterated robots array, like robot idx is equal to robot length, then just return 0. Or there could be another base case, which will be we have completed the factories but we are left with robots. In that case, it will be like factory idx is equal to factory length. We need to return max of numbers. And after this thing, just take min of both of them. Either take or not take. And just return this out. So I hope you have got the intuition. Let's try to write some code. So what is our approach? First step is sort robot array. And second step is create factory position. Third step is find min distance. So how do we sort this robot array? We can use collections.sort robot. We will create list of factory position, and now we will iterate on factory, and just like over here. So at second position, we have capacity 2. So we will add 2 times. So to iterate on factory array, we can do something like this. Now we just need to add this 0th index. How many times? This many times. So we will write a for loop for that, which will look something like this. From I to 0 and the number of times factory is there, or else capacity of the factory. Add the 0th index. So now factory is created, robot is there, but we need to sort factory position as well. So to sort this, we will just use collection.sort. Now everything is sorted. Now we need to just find minimum distance for each robot. So for that, I'll create a helper function which will be calculate minimum distance. Now initially we will be at 0th robot and 0th factory, like calculate minimum distance, 0th robot, 0th factory, and we have provided robot list and factory's positions. Now let's try to write some base cases. If the current robot's index is equal to robot size, that means we have iterated all the robots and we have repaired all of them. So we will return 0. But if our current factory index, which is equal to factory's size, that means there are some robots which needs to be repaired, but we don't have factories for them. So we will return just this max value. Now our logic, which was take or don't take. Let's say we are taking it up. So it will be take. We need to calculate distance. So the current coordinate of the robot will be this and the factory will be this. We will subtract and take its absolute. We will get the distance. Now we need to add remaining robots minimum repair distance. So for that, I'll call my recursion function, which will be this. Now we have repaired our current robot. So we will repair the next robot, which will be this. We have utilized current factory to repair this. So now we will use the next factory. So it will be +1. So this is done. Now let's say we don't want to take. So don't take. So how we will write this is, we will just use this recursion function. But over here, we will pass current robot only. And we won't be utilizing current factory. We will be utilizing next factory. So I've done this. Now we have take, don't take. Now what we have to return? We need to return min of take and don't take, which will be our answer. Let's try to run this. We are getting some long error. What is that? We are returning long's max value over here and we are trying to add something over there. So we are getting out of bounds. What I can do is I can make it divide by 2, let's say. And after running this, all our test cases are passing. Let's try to submit this. We should be getting a TLE. And as you can see, we are getting a TLE. Why? Because there are some robots for which we are recalculating some stuffs. So how we can solve this is introduce DP. What this concept is known as memoization. So I've added a DP array. Let's initialize this DP array with robot size and factory size. Initially, everything should be -1. Now, let's say if the current index sum is already calculated, which means if it is not equal to -1, then what we can return? We can directly return this pre-calculated stuff. Now we need to store this as well. So to store this, we can do something like this, and this is how we can apply memoization to any recursive solution. I hope you have got the solution. Let's try to submit this code now, and as you can see, this is running perfectly fine. Comment down if you are still facing some issues. Thank you.